All right, hello, math time. Mr. Beeland here with your lesson for today. We are talking about zeros of functions. Okay, so this can be talked about in two different ways. The first is talking about it graphically, and then the second is algebraically. So we'll start with the graphically piece. Okay, so what does it mean for the zero to find the zeros of a function? It means to find any of the points at which the graph crosses the x-axis. Okay, so I've got two functions graphed onto this here, and I'm going to try and find all the points which the function passes through the x-axis. Okay, so again, let's look at this green one first. It's just a line, and we can see that it crosses right here at x equals 2. So our zeros for this one are 2. It only crosses once, it only has one zero. This one here, this blue one, this is called a parabola, and it crosses twice. You see it crosses here and here. So if you look at this one, this is question 3 on the notes here. Question 2. And if you look here, it crosses here and here, and this right here is -2, and this right here is 1. So this has two zeros, one at -2 and one at 1. A function could theoretically have a whole bunch of zeros, right? It's not just 1, it's not just 2, it could be 50, who knows. But with the stuff that we're dealing with, 1, 2, maybe 3 zeros is, manageable. Now, when we're talking about algebraically, we are trying to find values of x such that f of x equals 0. So we're going to try and find a value for x so that the whole equation equals 0. So this is our function here, for example, f of x equals 4x minus 8. And we also know, again, we want f of x equals 0. So if this equals this, and this also equals this, that means that we can rewrite this as 0 equals 4x minus 8. All right, we just take that whole f of x piece out for now. Now this is just a two-step algebraic problem, right? So I'm just going to erase this here. I'm going to erase this and put a 0 there so that I've got some room. Okay, so how do we solve a two-step algebraic problem? First things first, we have to add 8 to both sides to get rid of this. So we get 8 equals 4x. And then we have to divide by 4 to get rid of the coefficient. And we get 8 divided by 4 is 2 equals x. So the zeros or the roots or the intercepts or the solution for f of x equals 4x minus 8 is x equals 2. Now, these can get trickier, right? These algebraic solutions or these algebraic questions can get more and more difficult as we increase the value on the power of the x, right? And eventually we'll get to the point where you can't really do it by hand or just through algebra. You will have to use a graphing calculator. That is outside the scope of what we are doing. You will be learning more about finding zeros of higher powered or higher ordered functions next year. For now, let's just work on these ones, okay? So there's a bunch more practice there, but don't bother with the questions 13 to 22 just because they are a little bit outside of what we're doing and we're not really touching a graphing calculator yet. Okay, that's it for today. Take care.